Let's look for another example. So we have here both the feedback control loop and also the combination of feedback and feedforward. So let's take a look to feedback control loop first. So this is the conventional control loop where this system is heat exchanger. So first we have to understand how the heat exchanger works. So we can notice that we have here the process flow has been recognized as the disturbance. So the process flow will go through the heat exchanger and exit the heat exchanger. So the objective of control loop is to regulate the temperature of the output from heat exchanger. So that is why we have placed the temperature transmitter at the output of the heat exchanger. So the heat exchanger is regulated through a control valve, where the control valve is regulating the steam flow rate entering the heat exchanger. So if we increase the opening of the steam valve, what will happen is the steam flow will be increased and the temperature of the process flow which go through the heat exchanger will also be increased. So to reduce the heat exchanger output temperature, all we need to do is to reduce the opening of the valve. So by reducing the opening of the valve, the flow rate of the steam will be reduced and therefore the temperature of the heat exchanger also will be reduced. So this behavior of increasing and decreasing of temperature will be monitored through the temperature transmitter, and the temperature transmitter will send the signal to temperature controller, and the temperature controller will send the signal whether to open more or to reduce the steam valve. So the problem is if the process flow if the process flow is becoming the disturbance. For example, the process flow rate changes from time to time. So this is definitely the problem, because if the temperature has been well regulated, let's say the temperature already achieved a certain steady state value and following the set value, but if the process flow rate suddenly increase, what will happen is the whole process will be upset and the temperature output of the heat exchanger will be dropped. So after the temperature output of the heat exchanger drop, then only the temperature transmitter recognize this behavior and send the signal to controller to take action. So if this process flow rate is occurring very frequently, so the control effort of the feedback control loop is not sufficient. So therefore we need another approach which is introduced here, where we need to place a flow transmitter to monitor the disturbance, and the flow transmitter will send the signal to the feedforward controller. And then we have summing controller over here, which consolidate the feedback control signal and also the feed forward control signal. So now the temperature of the heat exchanger is regulated by monitoring the output flow rate and also the disturbance, which is the process flow rate. So if the process flow rate disturbance occur, the flow transmitter will send the signal to feed forward controller, and a proper action will be taken to the steam valve without waiting the whole heat exchanger temperature to change. So meaning that the process control can be more efficient as compared to the one without the feed forward control.